Hey everybody, welcome to Houdini Hangout tonight on the 12th of January. Hope you guys are having a great day today. Just got a couple things that we're gonna, go over today, try to work through. And yeah, as always, I, would love to hear from you guys, like just hear if there's any questions that you have or any comments or whatever. I want this to be kind of an open forum, allow people to just kind of ask questions and see what's, kind of learn about Houdini and bring questions and hang out, and hopefully we'll all learn something new. So, yeah, tonight I'm going to try to go through some more PyroFX. It should be a pretty simple setup, just using some of the basic tools. And hopefully for anybody that might be a beginner, that might be a good, introduction to it. And once I've got that in a decent spot for the evening, I'm probably going to move over to working on a bit of a procedural chain link fence for a project that I'm doing for Formula One. So, well, a Formula One data visualization. I'm not working for Formula One. But yeah, so let's dive in and start playing around with some Houdini. So I was messing with this the other day, and I kind of I wasn't super happy with how it was turning out, so I figured I would start over again with it and just kind of get again from scratch and start to see what I can get with this pyro setup. So let me just kind of adjust my screen here a little bit. And the first thing I'm going to do is put down GeoNode, and I'm going to start, just going to go up here and rename this real quick. Call this sim pyro. Usually color code my nodes, so I'll color code that purple and dive in here. Also, I'm gonna save this. That was the original one I was working on. All right, so let's do we're gonna do a pyro burst source node. Drop that down. Cool. So we've got this ground-based explosion, and it'll be animated for a few frames and then go away. So what I want to do is use this as my sourcing point for my PyroSim. And the way that SideFX has kind of adjusted their Pyro workflow is a little bit away from trying to do everything kind of straight from geometry to more of this particle-based sourcing method. So each of these kind of branches of this like little explosion here on the ground, they start with attributes on the points. And so if we look at this, we can see that there's burn, there's density, there's a p-scale attribute, which is the point scale, and temperature. And so all of those things are going to help drive our pyro simulation once we get a little bit further down the line. So this is a good way to kind of get a beginning point for how the shape of our pyro sim is going to go. So what I want this to do is kind of be pretty contained and just come up in sort of a shallow cone type of a thing, and have it start a little bit more contained and not be like this like big spreading kind of fireball that a lot of stuff you see out there. So again, this is just the default shape. There's nothing really crazy here. I'm gonna just change the spread a little bit here, adjust the spread angle, maybe just have it a little bit more directional so it's kind of coming up. And so it's just over 5 frames there. We've got a bunch of different sources here. We can change the the distribution and everything of them. We can change the offset of it here. You can see we can randomize this right here. There's also a bunch of other options here that we could do for a burst type, but we're going to just go with an explosion. So let's see if we can find one that's sort of interesting looking. Yeah, I kind of like that. That's good. And what I'm also going to do is throw a camera in here because I want to see. Well, actually, I'll do that shortly. But I'm going to eventually want to get kind of this thin. I want to use this for an element on the streams here. So I'm just going to do like a thin strip of an explosion, basically, and just basically just render out a small area. I don't need to render out a bunch of extra stuff when I'm going to crop it down to a little tiny bar. So I just kind of want to get that set up more or less so that I can, that I don't have to spend time on stuff that I'm not going to end up using. So anyways, this pyroburst source is going to give us our initial points. You can see we've got 61,000 there. Another thing that we can adjust is the trailing separation here. That's going to either make more dense or less dense points. Obviously we can go like crazy with that, and that would be horrible. It'd be too disconnected. So for right now, the trailing separation will be fine. I'm going to kind of just work in the default scale that Side Effects sets up for you. And I'm going to just start going down and just getting us to a pyrosim, and then we can kind of tweak and adjust things as we go. So pyroburst source is first. And then we're going to volume rasterize attributes is the next one. Now, I'm kind of stepping through this piece by piece, but if you wanted to, you can actually go in here to Pyro, and you can actually do the Pyro configure fireball here. And if you drop that down, that pretty much will set up the whole thing that you want to do here. This is the chain that I'm going to make, but I just kind of want to step through it one at a time to show you kind of how this all works out. But just know that you can do that and get some pretty instant results from that as well. So haven't all selected. I'm just going to get rid of that because we're going to do that all on our own. So here we have the volume rasterize attributes. And we're not actually seeing that yet because the voxel size isn't small enough yet. So, and we don't have attributes set up here. So we've got density that we need to set up, and we want to do temperature as well. Velocity we should do in there. And, oh yeah, burn as well. So all of those attributes are loaded in here now, and we're starting to rasterize those obviously into a volume. I'm going to set this back because I was actually mistaken there. I was thinking that was why it wasn't coming up. But so there is our start to our explosion here. This is where we're turning our points, taking those attributes and rasterizing them into a volume, into a voxel grid. You can see down here I've got my voxel readout, and it's about 475,000 voxels, which is actually fairly small. It's not a huge amount or anything like that. So so that is the start that we're gonna go into the pyrosim with. And when I can type down pyro solver, and we're going to load that in there. And now this is going to be the beginning of our pyro simulation, and we can just kind of start playing this through, and we'll see that this is going to make a little puff, and pretty much that's it. But we obviously want this to go a little bit further than that. So what I'm going to do as well here is I'm going to tie the voxel size from this and paste it here. So I just right clicked and copied, then I'm right clicking here and doing paste relative references. And basically that's just going to make sure that this volume rasterize attributes, the voxel size is coming over into the pyro solver and is being driven there, just a way that you can link them together. So just to reiterate that, you right click here and copy your parameters, come over here, right click, you do paste relative references, and that'll link them together. We can see with this like dark green color here that those two are linked, and you can see the channel that it's calling. 2 dots means go up 1 level, then across to volume rasterize attributes, and then down to voxel size. And if we go over here and hover over this, we'll see that this parameter is named voxel size. So just for those of you that might not know those things, that is how you can link them together. So let's just check this out again here. Yep, starting to get a little simulation there. That one's a little slower just because we upped the voxel size as well, so that's obviously going to be doing quite a bit more calculations. We could kind of go in between, get a little bit faster sim, and that'll probably do pretty nicely for mix of speed and quality. So again, to reiterate, if you're joining us tonight, please, you can let me know where you're watching from, or what you're interested in, or whatever you'd like to know. If you got questions, please drop them in the chat. And I'd like to kind of have this open for people to be able to ask questions back and forth. Just don't want this to be me talking the whole time. Want to be able to have some, interaction with you guys and know what you're interested in learning. So, so we've got the Pyro solver here, and I'm also going to drop down the Pyro bake volume node, and this is actually going to allow us to kind of adjust our look and feel of our Pyro simulation after the fact here. So we've got we've got our smoke, but we want to add in some fire and things like that. So if we turn these fire attributes on, that's going to allow us to be able to start building some of these things in here. So I am going to initialize an explosion here real quick too, because this is kind of a new thing that they've added in here. It's a quick way to be able to just pull a setup that they might have made for different options. In fact, you can even create the pyro look right here, and that, if I took this out, pyro look right there, that'll actually drop that pyro look node down below it. So that's an option as well, to come up here, create a pyro look, stuff like that. So that's an option as well, to be able to kind of create this starting point for doing your kind of look dev for your explosion. So so this is starting to do its thing here. I'm just going to make sure that my burst components are doing what they need to here. Yep, I've got density, I've got temperature, I've got burn. Those are all good. And I'm going to just check here to make sure that I'm getting all those here as well. And that is the problem. I don't believe I had... Oh, sorry. I got to go back here. Let's see where it is. Yep, temperature, burn. Was that the issue? No. Okay, cool. Density, we're going to go in here and just make sure I'm sourcing in everything. We've got density sourced in, temperature, burn divergence, and velocity, and that's all going well. Let's take a look at this here, why this isn't. Just looking to see why this isn't showing me the explosion for some reason. Let me just turn this off for a second here, make sure that's not what's causing our issues. Huh. That is very odd. I don't know why that's not giving me the look I'm going for. But anyways, what I'm going to do is just, for the sake of argument here, I'm just going to drop down the Pyro configure fireball just to get us started with that there. And just adjust these. So this was at 50. Yeah, I don't know what I missed there, unfortunately. Odd. Very strange. Anyways, cool. So we've got our explosion coming in here. And then we've got a look down here that's gonna help us create, you know, kind of the glow and obscure stuff based on the you know, the density. There's some masking that goes on there as well. So what I am going to do here is go back and adjust some of these things. We've got buoyancy's looking good. We've got those all set. All right. So one of the things that I would like to do is kind of break up these just a little bit more. Make sure that we're not getting too much, you know, chunky edges there on, you know, on our fireball. And also sometimes you notice that there's this like kind of noisy masking that happens there. And I like to try to fix that a little bit, make sure that we're not seeing that quite as much here, so we can kind of adjust these two parameters to make sure that we're not, you know, getting too strong of a blocked, you know, kind of the fire getting blocked by our smoke channels. So that's those are a couple things that I like to do there. So what I'm kind of trying to do here is make a narrow kind of slit that I'm going to use. So I kind of want to see where this explosion is going, and ultimately where you know, see kind of what it's looking like. So I'm going to make a camera as well here. So let's just jump back up here, drop down a camera, and I'm actually going to rotate this sideways like this, because I want it to kind of go across. And so this will allow me to kind of do that. It's a little, maybe a little disorienting at first, but I think when we crop it down, it'll work pretty nicely. So I'm just gonna use these controls here if we need to. We can use these controls to you know, dolly in and out, and adjust left and right to kind of get the look that we want. This will rotate your camera, so we can kind of move this around and get, you know, get it coming up like that and kind of going across the frame as so. And what I want to do is also change the view of this camera. So I want to set it so that it's narrower, so I'm not seeing quite as high high area, you know, high from top to bottom. So I'm just going to do that. Maybe do it by about 100 or something like that. Actually, you know what? I'll do it at 200. And then that way I've got a little bit of room to play with it if I need to in the resulting sim. Because I want it to kind of travel across like that, where it's, you know, I'm kind of using the gravity, the buoyancy to allow it to go up. And as it's going up, it's going, you know, from left to right in this case. So I'm going to unlock this and just hit spacebar and G just to kind of jump me back into you know, standard worldview, so I'm not on my side like that. And so we've got this pyro burst that's coming up, and kind of want to tweak that a little bit more. So let's just look at some of these parameters here. Since they got kind of reset on me, I want to make sure that this is actually doing what I want it to. So overall expansion. So these things here, this will change how much the explosion is expanding if we go way up higher. Obviously now when we go back to our look, this is going to start and just go way gigantic at the very first few frames, and it's just going to continue to spread and make this gigantic, absolutely ridiculously huge fireball. So we want to make sure we keep that in a reasonable range. Let's go back to this. Selecting this top node will allow you to kind of view that without having to do any real calculations here. It's very lightweight. You can kind of scrub back and forth really easily on the Pyro burst source. And for this, we have 10 frames of duration here. It looks like it's also starting on 3, so it goes 0, 2, or 1, 2, and then on the third frame it starts and it goes up to 12. So that's our full expansion there. And just want to make sure there's nothing else here that I would want to do. Actually, what I'm going to do is I'm going to change the shape of this just slightly. I think I said I liked the number 8 one. Yep, that's cool. So let's go back here. Just take a look at how that kind of changes things. So that starts a little more directional right in the middle, so it's not going to spread out quite as far, which we don't need it to go out. And then it's going to keep going up like that. The other thing I can do if I want to speed this up a little bit, since we won't be seeing either side of this here, we won't be seeing this and this, what I could actually do is adjust my bounds here to limit the maximum size, and take this and hold down shift and just adjust it so that we're cropping off a little bit of that outside information. It's not a ton, but it'll help speed up the calculation just slightly, especially since there's so much here and here that we're top and bottom that we're not going to need on this. So it's kind of a nice way to be able to get a little bit of performance back if you so desire. I'm also going to just make sure that we have the room below, so we're not like cutting off any temperature or things like that are getting sourced into there. So here's our explosion as it comes up. You're going to see that these ends are going to start getting trimmed off here, and that's fine. It's not really gonna. I mean, it's gonna stop the calculation from happening out there. In fact, it's kind of interesting to look at too, just to kind of see like a 2-dimensional slice of it. But obviously this is saving us some resources to calculate and things like that. So, okay, that's looking pretty good. Cool, resizing. The one thing I want to tweak a little bit here is under disturbance. I feel like I want there to be a little bit of a finer disturbance. And maybe even have the control field with the speed starting a little sooner. I feel like it's starting, when we watch this start right here, kind of looks like it's just this big blob for a while, and then it starts to have this disturbance added into it to start, tweaking the outside edge of this this kind of moving front of the simulation. And so what I want to do here is I'm going to try to turn this control field with speed down just a little bit. Try to like 0.05 and see where that gets us. Kind of hoping that that's going to start breaking this up a little bit sooner, introducing just a little bit more disturbance in there. And it does kind of look like that's happening a little bit in there. I want it to be breaking up some of those edges and things like that sooner. So let's see here how this is looking. It's kind of fun. Black on the side there. So we've got our fireball going up here, and the turbulence. Let's just kind of take a look at what they've got going on here. So the turbulence they have animating, starting at the start frame and going up as we get into it. So it looks like start frame plus 12. There's a fit parameter right there. and that basically what that's saying is start using the FF or the float frame. Change that from the start frame channel, which is in here, I believe. Or no, I'm sorry. Is it? Where's the start frame? It's in here somewhere. Oh, right here, up at the top. So start frame is 1, and using that, because if we look at this here, it says parameter start frame. So if we take the start frame, that's the low part of our fit interpolation, and then if we look at the channel start frame plus 12, it's going to go from frame 1 to 12, and it's going to change the turbulence from 5 to 0.05. And I believe what that is doing there is allowing the simulation to start with a stronger turbulence at the beginning and then kind of lighten it up, because really strong turbulence can be super distracting in if you have it too strong in there, it'll just kind of push everything around and be kind of, out of control. So so that is what is happening there, and this disturbance is also what's creating this kind of rippling on the front of this. If we turn this disturbance off, what we're going to see here is this is going to remain very smooth on the outside like this, and it's going to start coming up, and it just keeps these like really unnaturally smooth edges to the pyrosim, and just doesn't look right at all really when you see that. So let's move through this again here a little bit. Let it simulate through. Get some of those nice ripples going on the top edge of that. And when we look at this, the other thing I want to do is just see. No, we have. Make sure that we're working with enough resolution to be able to start to visualize what's happening here in our sim. So I am going to turn this down just a little bit because I feel like we're just a little too high on it. So let's do 0.75 here. Go back, start playing that down, and you're going to see quite a bit more detail here. It's going to take a little bit longer to kind of simulate out the these frames. And in fact, what I'm also going to do is up my cache memory to 48 gigs, just so it'll hold a little bit more here, and I don't have to, I can scrub around and not have to resim or anything like that. So this is just going to roll through for a few frames here. We can also see here the one thing that you can note is that we're running a sparse simulation, which basically means that you can take this entire bound and work just in these active voxels in the middle here, which are denoted by this like stepped grid here, and those volumes are or those grid areas are where we're actually doing the simulation. We're not doing it across the entire bounds here. We're just using it right there. And in fact, you can also see that this is the outer boundary of that active region as well. And so there is our, this is the being created by the disturbance, all these ripples here. So I'm just going to tweak that again a little bit. Unfortunately, it looks like when we adjusted the this disturbance here, it looks like it actually might. Oh, that's the wrong that's the wrong attribute or the wrong number to put in there. I'm going to put 1 in there, set it back, see where that puts us. It's looking pretty good. So yeah, this is pretty straightforward, nothing too crazy here. Let's take a look at this scatter and just play with this mask a little bit and see if we can't get this to look a little bit more I guess realistic. There we go. That's starting to feel a little bit better. Just gonna. I'm holding down the middle click wheel on my computer to just kind of adjust these more finely. Um, these values are a little looking to be a little bit finicky here, so I just want to make sure that these are going to be, what I'm looking for. So feels actually a little too strong there. So let's adjust these here. That's feeling pretty good. A little less crunchy. When we get it into, I'm planning to look at this in Solaris using Karma, and when we get it to that point, we can look at the how the shading is actually going and kind of make some decisions from there, and see what actual things are going to make sense for this simulation here to make it look as as accurate as we can, but also make it look not maybe as noisy here on these edges. And you can play with that with your shader and stuff as well, because really all we're doing right here is telling the simulation what to do, or telling the system what to do with our values that are coming from the simulation. So here we're just adjusting this scatter scale based on the attributes that are coming out of this simulation. If we go back up here and turn off our look completely, well, actually just leave the smoke density on, right, and set that to something lower like 10, or even just 1 or somewhere in there. We can see just that this is just looks like a very standard volume. There's nothing really happening here. It actually plays back quite a bit faster because it's not doing any of the processing of the what do you call it, the scatter that's happening inside of the volume. So that can be a little bit of a saving of playback and stuff like that. It'll actually allow you to play it back a little bit faster. But yeah, let's I'm also going to turn down this the disturbance again. It feels like it's actually disturbing it too much right there. It feels almost like it's like pushing it out and in to a little bit too hard. So I'm going to go to the shape and disturbance. I'm just going to turn this down to, I don't know, 10. Let's try 10. See where that gets us. And maybe even just turn the roughness down a little bit too. Roughness a lot of times will really, kind of up the noise, what the impact that the noise is having on your volume. And I feel like that might be kind of contributing to some of that really intense, really rough look that's going on there. And yeah, that definitely looks like it's taming it down a little bit. So that's good. That's definitely helping a little bit there. Let this roll through a little bit. Again, if you have any questions or want me to work through something, or hey, just like, hey, I've been thinking about this, and I'd like to see what that might look like, or how you might take that, drop a comment in the chat, and I'd be happy to to talk through it and work through it. Once I get to a spot where I can, step away from whatever I'm working on. So please feel free to drop a message in there, and we can kind of talk back and forth and figure out, whatever you might be working on, or project that you're doing, or trouble that you're having with a certain concept or whatever. So yeah, happy to do any of that kind of stuff as we're going here. So I'm not the expert on Houdini. I've been using Houdini for about 5 years now. Just looking to have a space like this where we can kind of all get together, chat, figure out what we're, what things we might be struggling with or coming having issues with, and that we can kind of come together and try to figure some stuff out. So just looking for a place to create like that. So yeah, anyways, so this is starting to come together. We're getting a little, getting a nice little explosion happening here. If I go back to my camera, we can see that this is going to rise up through the view like that. And if I turn this on, we should see some of that glowy pyro. Oh, so sometimes you'll accidentally, move your playhead down into an area that hasn't been simmed yet, and you can see now that the computer's trying to simulate this. Well, I think you can. Actually, you might not be able to read that on your screen, but basically the computer's trying to calculate that. So I'm just going to hit escape and jump back into this blue area where it is already simmed. I just wanted to see what kind of the color was looking like and stuff like that. And it's looking pretty cool. I think that'll be a neat effect. The other thing that might be happening here too, as I'm watching this, is it kind of seems like the top of it is really pretty flat. I think that actually, hit spacebar G just to kind of reset the camera. I have a feeling that that's flat because we're not expanding quite as far as we need to. So as a pyro simulation like this, especially in the new SOP that they've created, as it starts to push upwards, it needs to expand the top leading edge of that explosion simulation, basically, and it needs to know how to do that and how much padding to add onto there. So if we look in here in bound, we can see that there's padding of 1 on it. So if I up this a little bit, let's just say to 2, just double that up a little bit, and go back here. Actually, you know what? I'm going to do that. I believe that's in world scale, so that's actually probably too much. So let's see how where this gets us. Because basically I don't want to stop those values from propagating upwards into new if they need to. I want to give the simulation the space to raise up where it wants to, but I also don't want to go too far and then cost a ton of simulation time and things like that. So I think that's starting to work. The other thing that you can do as well is we can take this simulation and swap it over into the minimal OpenCL solver. And this is a really different thing because it actually it kind of changes the way that it's calculating these values and takes out a lot of the sort of extraneous calculations that might be happening and kind of gives you an idea of what your sim is going to look like with a pretty low a low amount of time. It pretty much can do it pretty near real time. This might cause a little bit of an issue because I got the resolution up a little higher. So let me just turn that down a little bit and we'll see more of what's happening here. Let's go back here. Yep, that should be being driven by the trailing separation up here. That's set by there. Okay, cool. So let's see here. The thing that I want to make sure with, yep, the sourcing is being driven by right here with 1 to 12. So that's good. That's all working right. So let's see where we can go here. I take a look at my GPU real quick and see if there's a reason that that's running slow. No, it looks like it's got plenty of renders. Oh, you know what? I wonder if it's my bounds are giving it some trouble. If that out at all. Interesting. What I'm going to do then is just set it back to dense and try using that OpenCL. See if it'll be any faster for us. That's basically going to the same type of simulation that that the sparse uses, but instead of doing the calculation on the CPU, it uses the GPU to do it. So that can give you a speed up in a lot of cases. Now, part of what you need to make sure you're doing here is getting enough room to calculate everything. And it's actually I believe when you start the simulation, it's actually going to it's going to take that area and try to put that into your GPU memory, and that's going to cause it a little bit, cause the RAM necessity from your GPU to be higher. So you just have to be careful with how high of a resolution and things like that you start setting. So this obviously seems a little bit faster, but I do also have the resolution lower as well. So there's some trade-offs with that. So we'll just go back to the regular sparse and let it do its thing. But all right. So why don't we take a look at how this is going to go into Solaris and render in there and see what that looks like. So for Solaris, what we want to do is we'll go back up to our object level, and just going to let this calculate a little bit further. Go. Stage. And I'm going to do, so this is our Solaris environment here. And I'm just going to go to import. Yeah, I'll do scene import all. Bring that in. There you go. We're actually seeing our Karma perspective viewport right there already. You can see it right here. I'm going to set this back to Houdini GL just so it doesn't have to be rendering anything. I'm also going to turn off the import materials. That will make more sense in a second here, but basically this is going to come in. This will come in without the material assignment so that we can then assign our materials in here that'll be specific for the Karma version that we want to use. So let's put down a material library node. I'm going to do XPU, which is going to be XPU Pyro preview. And we will assign that. Autofill these materials just to make sure that comes in. Actually, you know what, real quick, I'm going to change this over to the Solaris viewport or the layout so that we can use those tools a little bit better. This will give us our scene graph tree down here, and we can see that it has our materials, the Karma Pyro preview. It also brought in the camera, so we can look at that, and we have our Sim Pyro volume that comes in with all of these attributes in it. The one thing I actually want to do is set that so that those come in as VDBs. So I'm going to click here, go back to the object level, jump into my Pyro Sim node, and go to the Pyro Bake volumes. Oh, I'm sorry, to the output of my simulation here. Go to export, convert these to VDB so that they're all VDBs. And you actually see that these all changed here as well. Just a little bit of a cleaner workflow. And a VDB is just a little bit of a more efficient storage medium. So even internally within Houdini, it just is a little bit of a nicer format to use to have your data moving around. So yeah, so we have the SimPyro loaded in here. We're going to go back up to the stage, in here, we've got all our VDB assets. You can see these here. The other thing I was noticing was my velocity was broken out into an X, Y, and Z value. They each had their own field. So I just made sure that by checking the, the output, the VDB, it actually goes in and it'll make it a vector voxel grid instead of just being, 4 or 3, float fields or whatever. So that allows it to just be a little bit cleaner in here as well. So, yeah, so we've got a material library. We can do an assign material node here. And what I'm going to do is grab the primitive that I want, which is the volume, and the material path, which is this Karma Pyro preview. I'm going to go into here and just set this. So I'm just going to rename this, call this Pyro shader. Nice thing about that is we know, oh, that's right. Because of that, I need to clear this and autofill this. Actually, what it did was it was taking the VOP here, this material VOP Pyro shader. It renamed that and was putting it over here as a different, as the original name that it had. So that was, I was like, wait, what did it just do? Solaris is still a little new to me. I haven't been using it in production stuff really too much. I've just started using it for certain projects and things like that. And it's really great as far as the XPU, the Karma XPU nodes and things like that, or workflow, which I'm going to show you in a second here. So we've got our material assigned. I don't really feel like I'm going to need any lights. But what I am going to do is drop down a Karma node. And basically this is like a fancy ROP that you would see in your in the regular SOP world, but it's like kind of all like tied in here and all mixed together. There's a ROP renderer and the properties are in here, and so there's a bunch of different stuff that's happening kind of under the hood. SideFX just packages this all together really nicely, so you don't have to do this kind of stuff every single time. It's all just driven from this one node. So if we come in here, set this to be our Karma, and then set our render settings to be the default. Yep, that's right. That's what we want. That's using the render settings that are coming from this node here. Now we're using this Karma node to drive our simulation, or our render settings and things like that. So I'm going to change this to be XPU engine. I'm going to restart this just to kind of make sure that we're getting the right settings going here. And I'm going to jump in here and start playing around with this, with some of these settings. So we can start pushing intensity here with the fire. If we want to just have the fire just to be kind of like all, the whole thing kind of coming through. And we can up the density on our smoke as well, maybe up to like 10. Looking pretty nice. And if we want to, we can enable our masking just like we had before. We can set that up, but really the better place to do that would be in this scatter. And the scatter is a much different kind of beast. So if we do this at like say 250 maybe to start with, and we enable this mask. So what this is going to do is it's actually taking kind of it's calculating how the light would scatter through this volume basically, and putting that right into the shader, which is a little different than how a lot of other render engines set up their Pyro, or whatever you want to call it, their black body radiation shaders and stuff like that. So I've used Arnold before, Redshift, things like that, and a lot of times it's just emission, maybe a scatter, but not for, it's more scattering like how the light is scattering through it, but not actually calculating this like fire kind of, explosion glow going through it, and then a density. So it's a little different the way usually there's like an emission field, and that's part of it. So in this case here, we're seeing, how this, you can see kind of how this scatter is coming through. You can see it's really strong in the middle here, and then it kind of fades out slowly. Whereas if we turn the fire up, that's just going to I'm going to turn the mask off here. That's going to basically put it everywhere throughout this whole, explosion that's going on here. So, you can do stuff where you have a little bit of fire in there, maybe you've got some in the background, and then you can also use your scatter as well and have that help out with everything and turn, kind of have those two things working together. Let's turn that up maybe a little bit just to make it a little more dense. And you can see how quick this XPU is. It's really nice, especially if you have a decent GPU and CPU, super fast. But what I'm going to do is turn up the samples just a little bit there. You can see how far this resolves and how quick it resolves. It's kind of crazy. Maybe 2 seconds, it resolves itself. So what we can do here is just kind of play around with some of these values and see, where this gets us, density scale of about 75. We can up the scatter to about maybe 250 would be good. And then just kind of play around with these mask values and the, the width of it and stuff like that. It's interesting that in here, the visuals, the visuals in here are so different than how they look in the viewport. I'm a little sort of confused by that sometimes. Like we look at this and then, that looks pretty good, but you get all this like banding and stuff in here. It must just be a downsampling in the viewport. Because even if I go in here and change the resolution, turn that off so it's not limiting the resolution, it still has all this banding and stuff in it. So I think that's unfortunate. I know they've changed that recently, but that's something, I don't know if anybody else has run into that before and, knows how to fix that. If you do, be cool to hear. But yeah, so that's kind of an unfortunate thing in the viewport. And it kind of tricks you a little bit into thinking like, oh man, my sim looks absolutely horrible. But then you get it in here and you're like, oh, actually it's not so bad, looking pretty good. Anyways, I'm just going to play around with this a little bit, see where we can get it. I'm just going to let this sim just a little bit further and see where, where how this starts to resolve. I'm just kind of curious when it gets up a little bit higher here, what it's going to look like as the fire in it starts to die out a little bit. No, unfortunately, I I pushed my my volume bounds in a little too far. I'm gonna have to tweak that, but no big deal. It looks to be pretty nice there. Let's take a look at what this camera looks like here. Oh, that's interesting. It didn't change the view of that camera. It's interesting. Well, what I could do, believe I can edit that. Let me just make sure that that's coming in properly here. Yeah, it is cam 1. Okay. So I'm going to drop this in here and make sure I'm editing cam 1. And then I can change this to be 200, I believe. And that should, there we go. Update. Cool. Oh, that's why. It's because the resolution here is resetting it. I didn't even need to do that. Let's see here. Yeah. So I just need to change the resolution here just because that's trying to overwrite it. Makes sense. You know, you don't want this is going to actually be the render area, but I just want to see what it looks like as just the thin strip here. Yeah, starting to get there. Yeah, you can see how responsive this is. Pretty nice. And that's more or less what I want it to look like. So we're starting to get there. It's starting to be something usable. Other thing I might want to do is just adjust the smoke color a little bit here. There we go. We want it to be white. We want it to be like a dark gray, and that's going to feel way more accurate. And yeah, it doesn't really do a whole lot with the shadow color there. The absorption color, yeah, it's going to be what actual color it's absorbing. If you set that to black, like absorbing the black in the volume, and it's just this kind of whitish yuck. So that looks a lot better. There we go. That's more what I was looking for. So the thing that's really nice about the scatter scale is that, as you see here, you've got this like glow that's kind of propagating down into this part of the volume. If we do just the fire and do it the same, it's not really going to have that same glow. It just kind of is all very like uniform looking. You can obviously, like I said, you can add those two things together and get better results that way. So 250 there, maybe 50 fire scale. You obviously see that has an influence now as well. So you can really crank that fire attribute, or you could rely more on scatter, tweak the smoke up and down. Kind of with it just like that. So cool. That's starting to look like something that'll work. So yeah, that's kind of the general workflow to bring something into Karma from the standard Houdini setup. And just as a kind of reminder here, you can see what we did here. This the pyro burst source and the volume rasterize attributes, driving this this simulation. And yeah, so that's kind of the look for right now. I'm not going to belabor the point too much. I mean, that's more or less what we were looking to accomplish. So I'm going to take a quick break here, and I think when I come back, I'm going to start working through some of my stuff for the Formula One project that I'm doing, and making the chain link fence that I've been trying to work on a little bit here, and I'll show you kind of where I'm at, and I'm going to kind of work through some stuff and try to solve some problems and things like that. So yeah, so that'll be the next thing that I'm doing here, and take a quick little coffee break here, and we'll be back. Thanks everybody for joining. All right, and we are back. I got myself a nice warm cup of coffee here, and yeah, we're gonna move on to some slightly different topic here. Doing some procedural chain link fencing for a visualization that I am doing to put out some Formula One data visualization type stuff. I guess I don't know. It should be cool, but it's definitely a lot of work. Got to make a lot of different tracks and maps and all sorts of crazy stuff. So, yeah, one thing that there is a lot of chain link fencing in the Formula One track world. There's a lot all around, so I figured that would be a pretty good thing to make, and just knew it was something I was going to have to do. So figured just we'll work on that a little bit and see what happens. Kind of jumping into the unknown a little bit. So yeah, let's do it. All right, so I have like a ton of different map um, nodes here that all have my map data from all these different locations and tracks and things like that. So I won't really be working with these, but basically just, I think it's enough to know that these will be the tracks that I'm using for, yeah, let's turn on all of them. These are the tracks that I'm going to be using for kind of where I'm laying down these different chain link fences. And yeah, as you see here, if you go inside of it and look at the high quality terrain, you can see here there's different, we can kind of see where this fencing would come in and all sorts of different things like that. So, along the edges of these, I'm going to put in the fencing just so that I don't have to, model too much. It's just going to be a procedural thing that goes around the edge of it. The view is pretty limited that I'm thinking I'm going to show the visualization with, because I want to show it up close and not too far off from the lead kind of car in the pack. So, anyways, these are the data sets that I'm going to be using for creating, the paths and things like that. But I started down here with my chain link fence. So I looked up a bunch of reference and chain link fencing and things like that, and I'll show you kind of where I got to with this. This is kind of the look for just the fencing itself. You can see there's some little bits at the end here that kind of are just the edges of this tiled grid basically that I created. And the way that chain link fencing, from what I could tell, I looked at a bunch of different references and things like that. In fact, I can probably pull that up and show what I was working on. Let me see here. Yeah, here we go. So what I was noticing was that these links kind of twist around each other, and they kind of twist back and forth. So it's kind of this like back and forth pattern. And so what I needed to do was basically take my geometry, have it kind of zigzag back and forth, and then as you can see in these pieces right here, it twists around, comes up, twists around, so it kind of has this like up twist kind of pattern to it. And so what I realized I could do was do a pretty simple process to make these chain links, and that is to take a line like this, and I gave it a few points, I think 11. And basically what I did was I grouped them, and I grouped, every other point. I used a group range and did one of two. So of every two, select one, basically. And oh, that's weird. I have three. Looks like I accidentally put three ranges in there. Oh, I see. I'm sorry. I did this a few weeks ago. So I basically just called it the group move, and that selects one of two and it offsets by one. So then I use that group here, the move group, to transform those points over and kind of create the zigzag pattern. And then I made sure, let me just see why. I think that was actually not necessary, but that's okay. So I used the poly bevel then to just make a solid fillet in these, and just add these points here, because what I wanted to do was take these long straight sections here and push some of them forward and some of them back, and then that would start to create that kind of looping back and forth pattern. So I sorted all the points because I noticed that they were getting out of order, because when I was doing this poly bevel, the divisions here were creating new points. So basically it was taking 0, 1, 2, 3, 4, 5 onwards, and then it was adding in 11, 12, 13, 14, 15, 16, 17, 18. And so I wanted it to be from 0 down at the bottom all the way up to whatever the highest number is, 28, I guess. Yeah, I think 28. So then if I sort it by Y, then it's taking 0.0 and just going all the way up to 28. So then this way, I could just have it a lot more orderly, and make a lot more sense, really, just from that standpoint. So if I needed to do any more grouping or anything like that, it would all be in order. So this convert line I did because I wanted to select every other primitive in this, or every so often primitive. You can see here that I'm selecting these top primitives here. And so in order to do that, I needed each of these segments to be their own primitives, right? And if you're not used to Houdini, I feel like a lot of programs call them, polygons, but in Houdini, they have primitives and polygons. And so that can be a little tricky. You can see here that we have 28 primitives, and it doesn't even mention how many polygons we have. So sometimes those can be a little different. Like these can be primitives here. Anyways, so when I use this convert line here, really all it's doing is breaking all of these up. It's putting all of these different segments as their own primitive. They're all still connected, but they're numbered. You can see from the bottom here all the way up to the top. And now I can select those individually as primitives, because I actually want to move both of these points to, I would have to select both of these points here in order to move this primitive forward or backwards. So in this case, it just makes it a little simpler, and I can kind of tweak things and move them and stuff like that. So this group range is doing two different things. It's making a front group and a back group. Basically, it's using this here to select 1 of 6 to do the back, and then 1 of 6 to do the front. And the only difference there is there's a little bit of an offset here. There's 3 primitive offset. So this is the back group that it's highlighting right now. So you can see that it's offset up 3. So you can see here how I can kind of push this back and forth, which is kind of a cool visualization, but that's how I can select either side of that and move them forward and backward. So then when I move down here, we can see this is the front transformation. And if we look at from the side, I'm going to turn these off just so we can see a little better what's going on here. If I hit the bypass flag, you can see that those primitives are moving. And then for the move back, those other primitives are moving. And so now I've got this zigzagged pattern where the corners are still, in space where they should be, and these other primitives have been pushed kind of out, forward and backwards, and that allows me to then take them, and I do a join here because I want them to all be one primitive again, because if I don't do that, then I believe it makes some weirdness with the resampling, if I'm not mistaken. Let me check. Yeah. So if I don't rejoin them, it won't properly subdivide these edges. So I do this to kind of create it back as one primitive top to bottom, and then, or one polygon top to bottom. And then when I do this resample node, the trick here is to make sure that this is set to subdivision curves. If I resample, which basically you can see I'm going from taking this only a couple points here to resample it, and then I have a lot of points from top to bottom. And if I do it this way, with straight edges, basically, you can see that it's not really curving those corners. They're still kind of faceted. And really what in this case, if I wanted that, I would select this resample by polygon edge, and that would make sure that those are all really nice, straight, hard edges. Instead, I turn that off. That starts to smooth it a little bit, but to really get it smooth, you do a subdivision curve, and that basically is like subdividing, that's like doing a subdivide on a curve, but also resampling it at the same time. So it's this is kind of a quick way to do this for, curves or open polygons. So so that starts to smooth it around these corners, kind of makes that nice little loop there. And now we've got this zigzag back and forth, and then I can copy this and translate it and rotate it as well. So it basically just 180 degree rotation and translation of 0.5, and that lines up to this initial move, I believe. This was a 0.55 move, and then doing 0.5 basically gives it a little bit of an overlap between the two. So this copy node right here, just making another copy and translating it and moving and rotating it. So now we've got this this twisting geometry going on here. Those are looped around each other, which is exactly what we want. And so we're starting to kind of build this up. One node that's really cool that I've found recently, I think they only added this recently to Houdini, if I'm not mistaken. It's this match size. It's kind of really helpful if you want to, just as the name implies, match the size of two different things. But it's also really helpful to just quickly, center something to the origin or to a certain plane or, anything like that. So that's what I did here. I just did a really simple, translate here, center it, X, Y, Z. And it has a target size here, but that's doesn't really matter. It's not like we're using that too much, but sorry. In fact, I wasn't. I was actually using that. I was scaling it just slightly in the x-axis. I forgot about that because I needed to overlap on the other adjacent pieces that are going to be all intertwined here. So I did add a little bit of this scale here, but it's just a really quick way to be able to kind of get some things that are like, this is exactly going to be 1.1 meters across, which obviously is too big for chain link fencing, but it's good to just work in kind of round unit numbers like that. So you can see here, if I hit the little eye icon here and look at my size, it's exactly 1.1, and it's just nice and easy to be able to know that that's exactly what you're going to get. So then if we start to look at this copy here, you can see that, yep, this is duplicating properly. We're getting that overlap that we wanted, and everything is really kind of working together nicely. Just going to go back a little bit here, make sure that's working out right. So, yeah. So then if we move this here to the origin, so what I did next, and this, arguably, you could do a lot of these things in, multiple ways. So, excuse me one second. So I decided that what I wanted to do was basically have a cut tile that I was just going to repeat, basically, to be able to scale to whatever size I needed for, panel. Like, so maybe these chain link fence panels might need to be, I don't know, 5 meters squared, whatever. I wanted to be able to not just like have to, keep scaling or doing this or that. I just wanted to have something that I could basically say, okay, do this, maybe they're all 1/10 of a meter chain, diamonds here that we're seeing. So do it 50 times across and then do it 50 times up, and then you've got a 5 meter or whatever. So what I decided to do is just kind of use these clip nodes here and just use a bunch of clips and trim it out to be the size, to be like a 1 unit size. Basically, you can see there the size is 1 by 1, and obviously it's extremely thin, but it would fit within a 1 meter box. And then that's our kind of individual link. And then what you can start to do is start copying these around, right? And these will, start to make that pattern. The only problem here is that these are all now, I don't need that on. These are all individual segments, primitive segments or polygon segments, whatever you want to call them. And so here you can see these are all separate. And that's going to be kind of a pain when I go to render it or do whatever. So I want these all to be back together. So that was what this last little step here was for. It just made sure that these are fused together. And basically that just means, like, if we come into these like really tight in here and look at these, we look at this area, we want to make sure that these points are fused and there's no duplicates in any of these sections here. Not sure where there was a duplicate point. Oh, maybe right here, I think. It looks like that's a duplicate point right there. So a quick way to check is just take your point selection and just, highlight that. No, that's only 1 point there. Let's see, where would it be? It's one of these points here somewhere. Oh, I'm on the fuse node. That's why it's not, it's not 2. Let's see here. Oh, it's right here. I can see it now. That's the one right there. So that's 2 selected points. If you can see right, it's kind of hard to see right there. 2 selected points. And so now when I select this fuse and go back here, it's just 1 selected point. So that basically just fuses together those points. We still have all of these separate segments, but now they're all fused back together. So what I can do is do a connectivity on them, and now this is going to know that those are all connected because they're fused together. So if I want to see this connectivity, which is creating a class attribute, I can go into this click on class, and now I can see all of those class attributes that are across this chain link here. And what I want to do is basically segment it out and basically refuse those together, which seems like kind of weird. Like, well, didn't we kind of do one thing to not have to do the other? But basically what the reason that I like this method for what I'm thinking of doing with it is that I can take these individual segments and adjust them to be whatever length I need them to be, without having to go, oh, well, this section is a meter, this is a 2 meter section of it, so I need 5, so that means I need to do 2.5 of these segments and all this math and stuff like that. That's just going to be goofy. Whereas if I have 1 unit that I can just duplicate over and over, to get the exact dimension I need, it's a little easier to do it that way, I think. So anyways, there's always more than one way to do everything in Houdini, and I think everybody knows that, but this is just the way that I chose to do it. Maybe it's the hardest way. If you have a better way, please throw it in the chat, and I'd love to know, what your suggestion would be for it. But Anyway, so that's what this next for each loop is going to do, is just quickly go through these and rejoin them back together so that they're all linked together. And so this connectivity makes a class attribute. This for each loop right here uses the class attribute for its piece. So what that means is that each class is going to come in one at a time. And if we do a single pass here and look, we'll see that, I'll turn these on just so we can see the points. We can see that each of these little chunks comes in one at a time, right? And each of those passes gets put into this loop. If you're not familiar with, data, computer science concepts and things like that, a for each loop basically takes a group of, it takes some sort of a set, array of elements and takes a function and basically loops over it. And so in this case, we're using that for our nodes, and we're going to do these two nodes right here over and over with it. So we're going to sort and join basically. So first what we get to here, I'll just do one single pass and make sure I can see it. Yep. So what we're going to do is we're going to sort by Y with both the primitives and points to make sure that it's in the right order, that we're not trying to loop anything back, because I'm pretty sure if I turn this off and look at it here, no, actually it worked out okay, but there was some weirdness going on, I believe, where it was creating some extraneous like lines around and stuff like that. So I'm pretty sure that sort was just making sure that there wasn't going to be any weirdness there. So anyways, that's just making sure that these points are sorted top to bottom and all that type of thing. So, and the primitives as well. So, don't need that. So now the join here, this basically makes sure that we join only the connected things together, and, obviously connect the closest ends. And now that joins everything in this one class or this one connectivity piece, and turns it into one primitive. So we look back down here and turn single pass off. You can see that each of these segments is now all connected. I could go through and select them. In fact, I'm just going to turn that off real quick. You can see here, you can select each and every one of these. They're all just one single like wire that goes all the way down. And we're kind of back to where we started in some ways, but this allows us to be able to kind of grow or shrink this however many we wanted. So if we wanted this, so this copy right here is what's creating this grid, right? So we go up and then we go over. So if I want to just change, how high this is, for example, I can just come in here and just shrink this up and down. And in fact, if I'm down at this end piece here, or this end node here, and adjust this copy, it's actually pretty quick. I mean, that's looping over all those, doing all those loops and all that type of stuff. And that's kind of the beauty of Houdini and the speed that it kind of gives you. So I can really easily know that this is, probably about 23 meters high by 10 meters across. Yep, and there it is right there, size 23 by 10. So that to me is really helpful, because I know that if I want it to be 23 meters by 10 meters, I can just throw that right in there. Now, if I wanted to do this whole thing and then have it transform down to like, a tenth of a meter here, now I know that this is going to be 2.3 by 1, right? So it's just, to me, it makes some really quick math that you can do in your head. That's super simple, and exactly what you're getting here. So now I know that if I want this to be, now I know that this is going to have a decimal place in it because it's getting multiplied at the very end. So instead, if I want this to be, say, 5 meters across, and this to be, yep. So that'll be 5 meters across, let's just say. I'm sorry, it has to be 50. 5 meters across, and then 10 meters high. This will be 100. And then we go down here and get to the transform. Does its whole thing. And there's our big old chunk of chain link fence there. So I mean, obviously that's probably a much larger chunk of chain link than we need, but it's done all of the exact same things that we needed, all of those pieces are linked top to bottom, except for obviously these edge pieces. And maybe I'm going to go through and crop them. I'm not 100% sure what the next stage of this is going to be, but that's kind of, how I went through and put all those, pieces together. So. On a side note, my wife really likes these big coffee mugs, but I tend to find that they actually cool my coffee down a lot quicker than I want them to be. So I should probably get a smaller one next time, less surface area. But she doesn't like her drinks quite as warm as I do. So, anyways, yeah. So this is the chain link fence. You know, little segment thing here that I can work with, and I'm just going to go back here, and maybe I'll just do this as a 5x5. I don't need to be 10x5. That's kind of gigantic. Yeah, that's good. Cool. No, I got a square again, but it's whatever. All right. So the next thing I think I'm gonna do is go into my track that I was starting to work with and see how to get this in there. So let me just save that, make sure we're saved. Yeah, so this was the track that I was working on here. It's a little bit of a mess, but basically what I was doing was I was bringing in my OpenStreetMaps data, and that is the Bahrain track, I believe. I don't remember the name of it specifically, but this is the border of the track. And yeah, I think so here I've got it so that this closed off this edge right here because it was open. If you saw here, there was a gap there. And that actually is accurate, but I think in the final one I would just put fence there and just there's no way to get in that's the pit lane there for the track. But anyways, so I resampled it, converted it a little bit. Let's see, changed it over into a individual segmented line, grouped it as the outside wall. Just want to see exactly what I did here. Sorted it. Oh, yes. I shifted it so that I believe so that the point sort would be ordered differently. Yeah. I had to do something similar to that to create the track surface as well here. So I actually had to draw this curve with a curve tool, resample it, and I used the imagery that I was showing you earlier to trace the outside of that, and then so then I grouped the outside of the track and the inside of the track here, merged them together, and did a polyloft across the two. And what I needed to do there was, actually that lined up pretty well. I don't think I needed to do much there. And then I did a polyfill because I think there was a gap somewhere. Where was there? There was a gap in here somewhere. I don't remember where. Here maybe? Oh, right there. There's a gap. And so I just polyfilled that in. So that's like the actual track surface right there. And that's like the blacktop. And so then I believe I brickered that for some reason because because I wanted to ray it to the I actually wanted to translate it to the surface of the geometry basically that I got. Like I actually had the elevation data in here from the from like Google Maps, from OpenStreetMaps. I actually did a stream about that a couple weeks ago now. But so this now lines up with that data. Then I just did like a simple poly extrude to give it a little bit of thickness down like that. And then poly beveled these edges here just so you don't see that there's a a big hard edge there or whatever, but it's actually doesn't look like it's doing it properly right now. I wonder why that is. Track edge. Weird. It's not, I mean, it's like beveling it like straight down. That's odd. Definitely know it beveled at one point. Must have changed the setting up here somewhere. Anyways, so that's the racetrack right there. So that's the surface of it. And then I also traced out this gravel surface here. And if I merge those together, you can also see the terrain, which I'm going to turn that off for a second. Nope, no, I don't want to do that. I'll just, I'll do a, there's a nice little switch off here that I can do and just throw that in there and just turn that off. So yeah, it's QLab if you are looking for that node. It's not in Houdini by default. That's QLab. Anyways, yeah, so this is like the gravelly part of the track. That's actually kind of incorrect, but might have to adjust that. Oh, that's where the pit lane actually goes in. So I was kind of just roughly selecting that. Anyways, it's kind of hard to just calculate all this stuff off of satellite data, but here we are. So that's the track so far, and now I want to start working on this fence. So let me see where I got with that. So these are the kind of, for whatever reason, I call them the fence roots, but basically the base of the, well, not the base of the fence, because this is the base of the fence, which is actually, I believe, geometry that I ran around. Oh no, that's just the base of. Not sure what's going on there. Oh, I see. It's the shape of the fence base. Yeah. So it's this it's basically just creating this what do you call it? A kind of a, what is the term they use? Cross section. That's it. Couldn't think of the word. Cross section that I could use. So basically this is the cross section for the base of the fence, and that's why I called it that. And so I sweep that over the root of the fence, and that will give me these little walls here, and those actually show up here as well in this whole setup. But it's coming from, was that just, sorry, just trying to see what I did a couple weeks ago. I think that's actually just some normal issues. That's weird. Oh yeah, it's just normals because I'm like moving back and forth, and it's like it like wants to put normals in there. I think I just need to add a normal node here. That might fix it. Nope, definitely didn't fix it. What is happening there? Oh man. There we go. That's sort of fixed it, but at least looks a little better. I think the problem there was that this was looking to set it as a point normal versus a vertex normal. A vertex normal is technically I believe the correct way of doing that. In fact, what I could probably do is just do this as a vertice, and just add these to the other ones as well, and that should. Oh, that's, yeah, that I can't even add normals to. That's actually a volume, and I'll drop this down here as well. Oh, that already has it. That's okay. Oh, I can just get rid of that. And now let's see. There we go. Now it looks much nicer. Yeah. So anyways, that is where I've gotten with this, and I want to do some stuff like, so I made some fence posts as well. That, nope, these are fence posts. There we go. And then I was trying to figure out exactly how I wanted to put these panels in here, more or less, like that. And so that's not working. Oh, I think I have. Okay, I think I have an idea for how to do this. So, um, yeah. So I was trying to copy these fence panels here, basically, and those clearly were not working. So, all right, I'm just gonna get rid of this. Delete. This is working though. These are fence posts. And so I basically took the roots of the fence here and resampled them. Make sure that they were connected, like fused at the ends. I made sure that the curve had an orientation on it. So that as it went around, I wasn't going to be getting like things tipping or turning or whatever as it goes around. And then here I copied the points, those the tubes that I made that are going to be like the fence posts. So if I look at this, you can see that these posts are all sitting on top of, on top of this like lower concrete structure. And I believe I have these. Let's see, these are all set to every meter here, it looks like. So those are 1 meter apart. And let's see. So what I want to do, I think, is I think I was trying to attach it to this curve here, right? I was trying to attach these fence panel, like these panels of chain link fencing, to these um, points here, basically, and have it in the direction that I want it to be to this next point here. But I think the actual better thing to do would be to get the center point of these primitives. Interesting. Okay, that's what I did. So what I had done here was I resampled this and I actually made each of these segments from this original conversion up here that I did. Actually, not even 100% sure why I did that. Probably not super necessary. So let's just look here. Does this break anything? I can always turn it off. No, that seems fine, other than the fact that there's a lot of. Yeah, that seems fine. Yeah, it doesn't look like that broke anything either. Unless. Did it change? No, it didn't. Literally change nothing. Not sure why I did that. Hmm. Oh, that's why. I was thinking I needed to do that for this to not be like a filled polygon, because when you do this, it changes it to just the line, and I was like, oh yeah, that works better. But I think I was just delusional. Anyways, sometimes that. Oh yeah, because I didn't like how this was happening, so I was like, oh, I'll just change it so that it's, um, this is not a filled polygon, and that's not gonna cause any issues. But it actually is fine. I think. I don't think it literally changes anything other than just being more annoying to look at. But that's fine. Excuse me. See where this resample gets me. I think that's gonna be. Oh yeah, yeah. Just have one of each. Two primitives. Mm-hmm. It's good. Okay, so now instead of worrying about that crazy, let's see, this is the curve that I want. Yep. Okay, now we're good. So now I don't have to worry about it being like, which primitive is it that I'm looking for this in between point and all that stuff. So now we can look here. We can see that there's fence posts. I'm just going to go to the outer one because it's a little easier to look at. So now we've got fence posts on each of those things, and I want to find this in between value of this edge, basically this polygon edge or primitive edge. So let's see here. I'm gonna do. Yeah, I'm gonna do a point wrangle. Nope, not gonna do a point wrangle. I am actually going to convert it back into a line though, because what I can do with this is I can actually take each of these individual segments now, and instead of doing a point wrangle, I can just do a primitive wrangle. If I could type primitive wrangle there. Now this is gonna loop over all the primitives, and I can just get the middle point of each of those, and that'll be nice and simple, and should be basically no issue at all. In fact, I might not even need to do a wrangle. I could probably just do a resample. Do segments 3? Is that no? 2. There we go. And should be the middle. And then what I can do is just do a UV here. Now what this is a node from AE and or library, whatever you want to call it, AE library, and which is made by one of the guys from Man vs. Machine. Great studio. And so basically what I can just do with this real quick is do some really easy, quick and dirty UV stuff on curves. So basically I could create this ends group here. And that should, if I'm thinking about this correctly, yep, looks like it does. Creates the ends group right there. So then what I could do is I could just do a blast node. Blast the ends. I've got the centers Look at that. Easy. It's just too easy, you know, sometimes. And then I can attach my panels to that. Now, I'm pretty sure that's still going to have that orientation data. Let me just double check. Good Lord, there's too many attributes. Oh boy. That's because this comes from the OpenStreetMaps data. And that is just a mess. Let me do some cleanup here. Maybe at this stuff here. At this point, I'm going to do an attribute delete. Not sure if it's needed down here, but I'm almost positive it is not needed. I'm not sure about this direction, but I'm pretty positive none of these attributes are needed here. So I'm just going to put a star under detail. That'll delete all my detail attributes because that's just too many. And then I think I've got like a million primitive attributes. Yeah, quite a few. So did I make any attributes here? I made some groups. Yeah, I don't really think I made. This just deleted the fence right there. Yeah. So, all right. So what I'm going to do is just keep, I'm going to do the same thing with the primitive, hit star, but instead I might just grab, let's see if there's anything here I think we might need. Class, maybe, might be helpful. Let me just see if what that is. There's not even data on class, it looks like. Oh, sorry. It is still deleting class. What I need to do is do a little caret there, and then that's not class. Okay, perfect. I guess that could come in handy. See if there's anything else here. Area. All this data came from, I guess I could do not name either. All this data came from the OpenStreetMaps, and literally nothing. That's pointless. And so some of it is just really seems like really bizarre things to be in here, like parking one way. So these are all like things that can be on OpenStreetMaps, but because it's a racetrack, a lot of it doesn't even exist. So it's kind of a little weird. But yeah. So anyways, that's fine. Got class. Good. No, scene view. All right. So now if we go back down here, we still good. Yep. Make sure this is still working. Seems like it is. Let's just turning off some stuff here so I can visualize. Great. Because I messed with that. Because I messed with those things, it actually, I believe it freaked out some of the data there. But where are those coming from? What happened there? Something did not like something else. Ah, I see. Okay. That was why I had to have this convert line in here. Well, if I do this, that should probably help us out and get us back to where we need. Yep, there we go. Okay, perfect. And we're back to where it was before. I think. All right, whatever. I could just do that and that. And kill this. That's right. Just breaking things live on the air. All right. So now I'm just going to do a join. No. Fuse. Boy, that's hard to see with that color on there. So what I did here was I did an orientation along the curve, and what that does is actually creates these up and n vectors. And there's right there is why I was having issues with this. Let's see. Now I'm seeing what's going on. Okay, so what I need to do is set this to get kind of back to where we were. I've got all these duplicate points here that I need to fuse back together, I believe. Let me just double check. No, those are just 1 point. Okay, so I don't even need to. I can just do a join in here instead. So they're fused. Do a join. Oh, right, they're fused. That's why there's no duplicate points. Join. We should have polygon. How's that possible? Oh, yep. Only connected ones. Right. Now we're back to this craziness. Okay. Interesting. Oh, that's okay. There's the fence roots, resample, transform. Let me just make sure that this is still working here. Seems to be working. No problem. Yep. Cool. And is this broken? Give it a second to cook. Nope. Perfect. All right. We're back. That's working properly. Then we're here. The in-between points. Perfect. Okay. If we look at I want to look at these normal vectors here in between and make sure that they're pointing in the direction that I want them to. They seem like they are. Let's just check like at a corner here and see. There is an issue. Those are not working because that is not. Let me go to the top view. Let's look at like one of these sharp corners here. It's a little tough to see. Okay, there we go. You can see that this isn't pointing the direction I want it to. It's kind of pointing at a sort of off direction. Yeah, see, and that's why, because what this in-between vector here is doing is actually blending between the two. So what let me just think about that. Orient along curve. So these are different ways that we can calculate where each of these, this orient along curve here is a node that can determine how the tangents of these curves are calculated. So what we're doing here in this step, which is a little tough to see, but I guess if I do this, yeah, there we go. In this orient along curve, we're determining where these tangents are being calculated. So now it's saying what's the next edge. Excuse me, the next edge. So this right here is the tangent of this next edge. This is the tangent of this next edge. So there's ton of different stuff that you can do here with these. So you could do the average of the end edge directions, the central difference, previous edge. So this is looking at the previous one. So this one is looking at this edge instead of looking at this edge. So you can see how these shift it basically. Next edge, previous edge. So this target up vector is basically trying to figure out which direction up is. So that's the y-axis. And just kind of seeing what any of these, if any of these are the things that I'm needing. It's interesting how that's changing that. It's actually changing the orientation of these points, which makes sense to some extent, but right. So it's just changing basically the pitch of how those are, what the up axis is for each of those. So, that won't be as simple as I thought it would be. What I could possibly do is instead what I can do is take these curves, kind of like how I lofted them together here, and instead what I can do is take each of these both have a class attribute, or they also both have an inside wall and outside wall group. Those are active. Let me take a look at that. So under geometry spreadsheet, no, it looks like only a couple of those are actually active at this point. But I could just select that, but that's okay. I know I can do this however I need to. All right, so here's what I'm going to do. Instead of this, I'm going to split these. And nope, don't even need to do that. Just make sure my class attribute here, I'm looking at the geometry spreadsheet. These have the same class attributes. So I'm just going to do a connectivity. Primitive. It sets those two classes. Then what I can do is do a duplicate. And then, so there'll be two total. Is for those to go up to the top of that, but that might be different because what might happen here is I might actually move this up, right? And due to the leaning of let's just convert this again. Oop. Due to these It's odd. That yeah, maybe this is like a redraw bug. Yeah, yeah. Found a redraw bug. There we go. It's like that didn't make any sense. This convert line should 100% not have those big polygons. There we go. Sometimes there's a little viewport bug in Houdini. Would love for them to fix that, but you know, the rest of everything is so good in Houdini. I can't get too frustrated about a simple little thing like that. But okay, here you can see exactly what's going on there. These, when I tried to just straight translate these points up, because some of these are leaning in different directions, they're not oriented properly. So what I need to do, I think, instead of this orient along curve, what I need to do is set it so that each of these posts go straight up, because I don't want them to be, tilted and stuff like that. So unfortunately, this is not doing what I want it to. So I'm just going to take my geometry spreadsheet here and split it top and bottom so I can read this and set this back to my scene view. There we go. Okay, so what do we have here? We have an up vector, which yep. So everything is fine there, but what I want to do is, instead of using this up vector, that it's oh, you know what? I could probably just set a custom one, right? It's gonna just, let's see here. That's kind of funny. If I just turn that off, it seems to be doing exactly what I want it to. Fair enough. You're off. Don't know why that was the case. Anyways, now if we look at these, turn these normals off. Look at those fence posts and look at these. They're closer. Perfectly straight up and down. Interesting. Oh, I see why. There's a little bit of weirdness going on there. So did I calculate? Oh yeah, that's why, because I did an orient along curve already. Mm-hmm. That's why. Already have an up and a normal. All right, well, I'm just gonna do this orient along curve again here. Leave that in. Let that calculate the right, tangents. And then I am going to, let's see, I'm going to do an orient QL node. This is from QLib. And so my aim vector is going to be N. My up vector is going to be up. And yep. All I need to do is set all the ups to be exactly the same. So if I go to, I'll just do a pointer angle. Might be a little overkill, but no big deal. So if I do v at up, setting a vector up attribute, and do a couple curly brackets, do 0, 1, 0, 1, 0, and then do a semicolon at the end. That sets all my up vectors to be 1. All these posts should now be sticking straight up and down. This is basically just creating an orient vector from those, just to make sure that, just to kind of clean it up a little bit. Um, it's an orient quaternion, I believe is the term. And then if I copy these to points, they should be straight up and down. Are they? Of course they're not. Why would they not be? If I look at these, they're offset again. Cool. All right, well, let's turn this off. See if that does it. Nope. That is strange to me. Those not pointing straight up and down. Tension being added in there. Nothing happening here. Okay. I think I know what's going on. I'm wondering if I delete these, yeah, but jump inside of there. If I delete the normal attribute, oh, it's being deleted here. So I'm going to get rid of this. Just going to use an up attribute. See if that works. I'm going to get rid of the normal here. No, that don't work at all. That must be because it's trying to calculate the normal there. Yep, yep. Although now, let me guess, those are those are directly up above it. Yep. So the problem here is that I'm actually, yeah, I'm running into the issue of needing these fence roots here. So these have all been like rayed to the terrain. I wonder if that's causing me these problems. Let me see. No, they're still going to be slightly off. So what I'm doing is I'm projecting it onto the terrain, and that's obviously causing there to be some issues. And when you calculate a when you calculate the tangents, the bitangents, the up vectors around a curve, if there's any like deviation up and down in it, it's gonna cause there to be some, you can't you can't set like an orient vector or orient like quaternion or whatever to not be, I believe you can't set it to be non-orthogonal. So I think that's where you're running into an issue where it's like it's trying to snap them all to right angles to each other, and because to start with they're not at right angles, that's causing an issue and causing me to run into some trouble there. So think, okay, I have another idea. So since that might be causing the problem, what I'm going to do is set all of these y values to be the same. So like, let's see, I can just get, could probably just average, So I'll take an average. Do this here. All right, let's see. Learning new things. Point, detail, average. Yeah, looks like I can't. Could I do bracket 1? Well, let's see that. No. Well, I might just be able to do P and get the average. Let me look at my detail attributes here. 54. Yeah. Okay. So it averaged each of the vector components. So 54. Yeah. So what I'm going to do is I'm going to set the y value. So I'm going to do v at p equals. I'll just do set. Let's do set component. Oh, look at that. I've never done that before. Set component, single component vector matrix. Yeah. Okay. So what I can do is I can set this to be just making sure I'm reading this properly. I'm just looking at this real quick. Okay, so I think the one I want is the top one. So I want set comp the vector with a float value and an index. All right, so let's see if I can do that. So this should be v at p as well, and then sorry. Value in the index. Okay, yep. So then the value would be detail. So I'm getting a detail attribute, and I want the current geometry. The attribute name is going to be p bracket y, I think. So I'll do this as a string, p bracket y. Just clean this up a little bit. Doesn't need to be so wide. And then should be a float value, and then set index. So that's going to be 1. That can work. I think it just set all my points to 0. Set all my points to 0, 0, 0. All right. No sense in doing it that way because I haven't used this set component thing before. So no big deal. I'm going to do a set and do at p.x. And then actually this would be that. Then this is going to be, I'm just going to make an a variable. I knew there was a word for it. Make a variable of, let's see, this can be a float, new y equals detail. 0. Y. All right. And then this should be new y, and then this should be at p dot c. Well, that all worked except for the y wasn't right. So let's see if I do it like this. Is that correct? No. That's really strange. I actually thought, hmm, well, what I'll do is I'll do vector new y, bring up that, then it's confused about new y because it can't exactly do that because that's like putting a vector in that and it's taking the first value. Yep. Okay. So we're good now. So now I could do new y and then take the first component. Hey, there we go. All right. So now everything is set to the average height of that. But what I want to do first is set a rest position, because then I can snap it back. So that sets a rest position. And for right now, actually think okay, so I've got that set. Good. This is now move to the average height. I can make sure I can recalculate this, orient along curve. Move this down here. Hopefully that is all working. Are these all straight up and down? That's the question. They look like it. And then if I do one more step here, if I do a rest position, if I extract the rest, that will set that rest position back with the same orientation on it. They should all be straight up and down. The fence posts should be sitting right on top of these still. Yep, because we set them right back to where they should be. Looking good. Looking good. There's those. Let's just template that to see. Yep, those are all still sitting right where they want to be. And if I look at this lines here and those fence posts as well, they're all sitting right at the top. So we have all straight up and down fence posts, and that goes at the top, which is how I'm going to build my panels for my chain link fence. So let's just do that real quick, and then I think I'm calling it a night because I am getting a little tired. What I'm going to do is take this tube, and I've got the height here. I'm going to copy that parameter. I'm going to bring it over to this copy node and paste the relative reference there so that if I did change these tubes to be higher, these other lines will move along as well. So just a little nice thing to do. All right, so I have those set, and what I should do is I could do like a for each. No, I'll do a for each primitive. But in that for each primitive, I am going to set it by piece attribute. This class, they all have class of 0. 0 and 1, copy 0 and 1. That's weird. I don't know why it's doing that. All right, so what I'll have to do is do one more tricky thing here. So I'm going to promote this attribute here. Oh, no, I don't need to do that. I can just calculate this on the point level. Class 0, 1. Then when I come down here, I can just attribute promote it back from point to primitive. Class, I've got a 0, I've got 1. If I come down here, this should be 2. And if I do a single pass, we should have the outside and the inside. Cool. So then if I do the polyloft like I did it before, which is here, just gonna copy that, paste it down here. Just make sure I'm not missing something here. Oh, yep. That's why. I have two groups here that don't exist, so that's why it's not going to do anything. All right, so when I copy it, I'm going to do copy group. Every step gotta be a thing. All right, so I'm going to do a group remote, since apparently only the point attributes go through. So I'm going to go from auto to points, copy group 0, copy group 1. So now those should be point groups, which they are. Oh, actually, I think this is looking for point groups anyways. Perfect. Set this cache pass just to make sure that that actually Copy group 0, copy group. There we go. Awesome. Cool. Now we actually have that we could that we can use for figuring out where each of these what do you call it, the chain link fence panels are going to go. And at this point I could do a lab quadrangulate. So now we've got nice quads all over here, and we can use those at the next stage of the project. But at this point, I am going to be signing off because it is 10:40 on the East Coast, and I'm going to save this and get out of here. So thanks for joining me tonight on Houdini Hangout. Looking forward to seeing you next time if you weren't able to join us live. And yeah, next Tuesday at 8 will be when we're going live. And yeah, I appreciate it if you've watched this live or recorded or however you may have come across it. So thanks so much for joining us, and I'll see you next time. Thanks.